Hello everyone, hope you are doing well. I am Akshay Parmar, Assistant Professor at LJ Institute of Engineering and Technology in IT/IC department. Welcome to the video tutorial series of the data communication and the computer networks. Right? So in this session, we are going to learn an error detection technique and checksum. Right? So what do you mean by the checksum? In the outline for the today's session, we have seen the VRC LRC brief. In this session, we are going to cover checksum with an example. So what do you mean by the checksum and where does it used in the data communication, right? So let's discuss the checksum first. So the checksum is used as an error detecting technique, right? So whenever the sender is sending the data to the receiver end, the sender is sending the n number of n number of the bits to the receiver end. That receiver is getting that n number of bit that is sended by the source. To confirm that, we are light on the error detecting technique, right? So if the error is occurred during the transmission, we can simply detect that error is occurred or not. So for that, we need an error detecting technique, and checksum is one of them. It's applied to the message of any length, right? So previous methods are applied with the fixed number of the message length, but here in the checksum it can be applied to the message of any length. The message with the n number of the bits can be used with the checksum, right? So checksum is mainly used with an network and the transport layer rather than the data link layer, right? So mainly the task of the data link layer is the detecting and correcting the error, but the checksum is mostly used at the network and the transport layer, right? After that, what do you mean by the checksum, right? So how it is working. So for that, how it is working, let's see, right? So data is divided into the case segment, each of the m bit, right? So the whole data, the n number of bits are divided into the case segment, and that each segment having the m bit in that, right? So that's how you are dividing your data, right? After that, at the sender side, what are the tasks performed at the sender side and what are the tasks performed at the receiver side? Let's start with the sender side. At the sender side, that segments are added using the ones complement arithmetic to get the sum, right? So segments are added using the ones complement arithmetic to get the sum, right? After getting that sum, the sum is complemented to get the checksum, right? So sum is complemented to get the checksum. Our whole data, the segments are added using the ones complement. By that we are getting the sum, and by complementing that sum we are getting the checksum, right? So that's how at the sender side we get an checksum there, right? The checksum segment is sent along with the data segment, right? The checkmate segment is sent along with the data segment, right? What are the tasks performed at the receiver side, right? We are curious about. All the receive segments are added using the ones complement arithmetic to get the complemented sum, right? So at the sender side, how we are getting the sum? Your segments are added using the ones complement arithmetic to get the sum at the sender side. At the receiver side, all the receive segments are added using ones complement arithmetic to get the complemented sum, right? After getting that complemented sum, if the result is 0, the received data is accepted, right? So we can say that there is no effect of the error during the transmission. If otherwise it is discarded. If it is not 0, then we can say that the error is happened there. Error is here only. So we can simply discard that, right? So that's how the checksum is working. At the source, the message is first divided into the m bit, right? As we have discussed that we have the n number of the bit sequence, right? So that n number of bit sequence is divided into the k part, and each part is having the m bit unit, right? After that, the generator then creates the checksum, for an example extra m bit units. At the destination side, the checkers creates a new checksum from the combination of the message and send the checksum, right? So that are the tasks that is performed at the source, and that are the tasks which are performed at the destination, right? At the destination, if checksum is all zeros, the message is accepted. We can say that there is the no effect of the error. The data is received as transfer as the sender has sent it. Otherwise, we can simply discard that whole message, right? So that's how we are discarding the discarding and accepting the message in the checksum technique, right? With the help of the checksum, right? So let's see how it is working at the sender side. You can see that we have the n bits of the data sequence to be sent, right? The message is having the n number of bits, right? After that n number of bits are divided into the k chunks, right? Then that each chunk is having the m bit, right? That's how we are dividing the whole message. After that, we are adding the ones complement to get the sum, and after that, after getting that sum, we are complementing that. So that's how we are getting the checksum of that sum, right? Or checksum of that message. That checksum is sent along with that data at the receiver end, right? So that receiver is doing the opposite reverse procedure to get the actual data, right? So the message plus checksum is sent to the receiver end by the transmission media. If the during the transmission media, if error is occurring, it can be vary in the checksum and that particular data, right? So at the receiver end, the whole data plus checksum is received. After that, it is given to the checkers, and they are checking the m number of bits. If all bits are 0, then we can simply discard that, right? If all the bits are 0, then we can say that there is no error occurred during the transmission, right? So we can simply discard the checksum from that that received data, and we are getting the actual data there, right? But if one of them is not 0, right? If one of them is 0, then we can say that there are the error occurred during the transmission, right? During the transmission, there are the noise effect and any kind of thing is happen, and the data is modified somehow. So we can simply say that we should discard this message because modified data has no use, right? So that's how the checksum is working at the sender side and receiver side, and we are that's how we are sending the data using that technique, and that's how we are getting the actual data by reversing that technique, right? So that's how the checksum is working. Let's see it by two examples. First of all, the method number 1. The 4-bit numbers are 7, 11, 12, 0 and 6. Message to be sent is 7, 11, 12, 0 and 6, and after that the sum of them, right? 7 plus 11 plus 2 plus 6 plus 0 is 36. At the receiver, it acts an actual number and compare with the sum 36, which is already sent along with that, right? So if the two are same, the receiver assume that there is no error and numbers are accepted, and sum is simply discarded, right? Else, if the error is somewhere, then data are not accepted because there are error there, right? So that's how we are accepting and discarding the data there. Let's have one example to getting the checksum and all that. Add two 16-bit integer words, right? So for that, the sender is the data 1 0 0 0 0 1 1 0 0 1 1 0 0 1 1 0. That is our first bit sequence of the 64-bit. That is our second bit sequence 1 1 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1, right? So that two are our bit sequence of which have the length of 16-bit, right? After adding that both the sequence, both the word, what we are getting? We are getting the wrap around, right? So how it is? How we can adding that 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0, and 1 plus 1 is 0, and that carry is forward to the next move, right? So 0 and carries forward, 1 carries forward to next move. That's how we can add the binary numbers. So let's begin with the end, how that summation is working. So our last digit, both the word are 0 and 1. So if we simply add 0 and 1. So we simply add that last digit 0 and 1. What we are getting? 0 plus 1. In the binary addition is 1 only. So we are getting that 1 at the last digit. After that, the second last digit was 1 and 0. 1 plus 0 is 1, right, in the binary also. So the second last digit of the wraparound is 1. After that, the 1 is there. So how you are adding that to 1 in the binary system? 1 plus 1 is equal to 0, and that 1 carry is carry forwarded to the next move, right? So the third last digit is 0, and its carry 1 is forwarded to the fourth last one, right? So there are already 0 0. So 1 plus 0 is 1, and again 1 plus 0 is 1. So that's how we are getting the fourth last digit as a 1. That's how you can get the whole sequence of the data, right? How the data, how that two integer numbers are added, we can see that. And we are getting, after getting the two addition of that answer, the 1 plus 1, that two sequence is, answer is 1 0 1 1 0 and so on, right? So the first digit is the carry, is carry forwarded in during the addition, right? So simply we can what we can do, that we can simply complement the sum, and we can get the actual checksums, right? So that's how we are getting the checksum by once complementing that wrap around sum, right? So that's how we are getting the checksum. That checksum is sent along with that data to the receiver end, right? So with the help of this checksum, the receiver can unsure about the data is authenticated or not, the data is modified or not, any noise is erroneous noise is encountered or not, and so not, right? So that's why we are sending that checksum with then our data, actual data, right, at the receiver end. What are the tasks is performed? They are simply adding that two integer number which is already got by them, right? After adding that, what they are getting, they are getting the wrap around at the similar kind of thing, right? So that wrap around is there. After getting that, they are simply they are simply one's complement of that checksum, and we are getting this sum, right? That sum plus our checksum, if we add them, if any bit is 0, then we can say that during the transmission any noise is encountered and that have the effect or in the data, right? So our data is manipulated or modified during the transmission, we can simply say that, right? So that received sum plus our checksum, if we simply add them, if whole the sequence is having the only one bit 1, then we can simply say that the error is not encountered, our data is pure, that how the sender has sent the data, the same data is received at the receiver end, right? So we can simply add that sum plus checksum, and we are getting that is the 0 plus 1 is 1, 1 plus 0 plus 0 is 1, 1 plus 0 is 0, 1 plus 0 is 1 plus 0 is 1, and that's how we are getting the whole sequence, right? So we can ensure that there is the no error. If one of the bit is a 0, then we can say that the error is introduced into the packet, right? But in our case is the no 0 is there, so we can say that the data which is sent by the sender is received at the receiver end successfully, right? So you can simply say that. Note, when the adding numbers, a carry out from the most significant bit needs to be added to the result, right? So note down one thing. So when the adding the numbers, a carry out from the most significant bits need to be added to the result, right? That's how the checksum is working, right? The actual working of the checksum that we have seen, right? So the checksum is working at a data link layer, is not working properly at the data link layer, rather it is working at the network layer and the transport layer first. Let's discuss CRC, right? So what do you mean by the CRC? CRC is the most powerful and the easy to implement technique, right? So whenever you want to detect an error, if it is occurred or not, you can simply use the CRC technique. It is the most powerful and easy to implement technique. CRC is based on the binary division. You have the one question arrives on what basis the CRC is implemented, right? So CRC is based on the binary divisions. After that, in the CRC, a sequence of the redundant bits are appended to the end of the data unit so that the resulting data unit becomes exactly divisible by the second and predetermined binary number, right? So in CRC, a sequence of redundant bits are appended to the end of the data unit so that the resulting data unit becomes exactly divisible by a second predetermined binary number. At the destination, the incoming data unit is divided by the same number, right? So that the task which is performed as the at the sender side, right? Because the task at the destination, right? At the destination, the incoming data unit is divided by the same number. If at this step there is no reminder, the data unit is assumed to be correct and therefore it is accepted, right? So there is no error during the transmission, so we can simply accept it, right? So that's the thing that we are following, right? A reminder indicates that the data unit has been damaged in the transmission and therefore it must be rejected, right? So erroneous data have no use, so we have to reject that, right? So at this step there is no reminder, the data unit is assumed to be secure or correct, right, and it is acceptable. But reminder is the damage during the transmission, so we can simply discard that or reject that. The binary number, which is r plus 1 bit in the length, can also be considered as a coefficient of the polynomial called the generator polynomial. That's all about today's session. In this session, we have seen checksum briefly, right? So in the checksum, where does it use, how it is working, and all the things we have covered in this session. So thank you for the watching.